This is GCSE Further Pure, and we're just moving on then to Chapter 3, Simultaneous Equations. So this is now going to be with 3 equations, 3 unknowns, so this will be new to us. We've done ones before with 2 equations, 2 unknowns. So our plan, as before then, is to number them 1, 2 and 3. And then what we want to do is come up with equations 4 and 5 by eliminating one of the letters. So I'm going to try and eliminate the y's. So let's see if we can kind of make sense. So why don't we write that down? So if we go for eliminate one letter, and in this case I'm going to go for the y's. The y's are probably the easiest to get rid of here, and hopefully you'll kind of see that in a wee second. So that's going to be y. So what am I going to do then with equations 1 and 2? This one's a minus 2y and this one is a 1y. So I'm going to multiply equation 1 times 2. Just the same as you would do for 2 equations, 2 unknowns. So times this by 2, I'm going to get 4x plus 2y plus 6z equals 18. And then I'm going to write down equation 2, obviously, which is going to be 5x minus 2y minus 2z equals 3. And we're trying to eliminate the y's here, so I hope you can see the way we're going to do that is by adding these 2 equations. So I'm going to be adding on 2. 4x plus 5x is 9x. 2y plus minus 2y is 0. That was the idea. And adding these, then plus 4z equals 21. And I'm going to call that equation number 4. We need to come up then with equation number 5. And the key to this is we eliminate the same letter. So if you look back then up at these, we have a minus 3y here and we have a y, so I'm going to be multiplying this one by 3 and then adding 1 and 3. But you must eliminate the same letter, so it's 1 times 3. So equation 1 times 3 is then 6x plus 3y plus 9z equals 27. And we're dealing now then with equation 3, which is 3x minus 3y minus 2z equals 3. And again, set it up here. And we're going to add these 2 equations and we get 9x. They disappear. Adding these gives me plus 7z. And that equals 30. And I'm going to call that then equation 5. So we now have 2 equations with 2 unknowns. We know how to solve this. We've been doing it for a couple of years, so we should be okay. So we're now going to eliminate another letter. The one I'm going to eliminate this time is x. Can you see that's a 9x and that's a 9x? So it's going to be nice and straightforward. So we're going to do 4 take away 5. In fact, you know what I'm going to do? 5 take away 4 in this case. 5 take away 4. So equation 5 is 9x plus 7z equals 30. And then 9x plus 4z equals 21. This, take away this. Obviously the x's disappear. This take away this, 3z, 30 take away 21 is 9, and so we have then that z equals 3. So we're up and running. We can now substitute the z equals 3 either into equation 4 or equation 5 to try and get our x. So we're going to substitute z equals 3 into equation 4. That means we have 9x plus 4z equals 21. It's just off the page there, but you can read it on your own. And substituting that in, then we're obviously going to go for 9x plus 4 times 3. Let's just write that as a wee line so you can see what we're doing. Equals 21. 9x plus 12 equals 21. Kind of overkill here. 9x is 9 and x equals 1. we now know 2 of our 3 letters. X is 1 and Z is 3. So if we substitute these two into equations 1, 2 or 3, right back up at the top in the question, we should be able to work out our last letter Y. So we're going to substitute Z equals 3 and X equals 1 into equation number 1. Equation number 1 says 2x plus y plus 3z equals 9. So 2 upon x is 1 plus y plus 3 upon 3 equals 9. That's going to give us then, if you work this out, that's a 2 and that's a 9. So those 9s effectively cancel the 2 over the other side then. So we have y equals minus 2. We can do a check with one of the other ones. We could check maybe with equation 2. But let's see. So we're okay for space. Check 5x minus 2y minus 2z equals 3, and it should give us the right answer. 5 upon our x is 1, minus 2 upon minus 2, minus 2 upon 3 does equal 3, and so that gives us a 5 plus 4 minus 6. 5 plus 4 is 9, take away 6, does equal 3, and so our check works. I always like to see the answers written out somewhere at the bottom, so let's go for x equals 1, y equals minus 2, and z equals 3. And that's 3 equations, 3 unknowns. Now be very careful. The secret here is you come up with equations 4 and 5, but you have to eliminate the same letter. Notice I eliminated the y and I eliminated the y here. That gives me then the 2 equations, 2 unknowns, which you can just kind of solve as you normally would have done from key stage 3.